I'm Derek Brown. I'm here with my colleague Alvin Singh. We're both engineers at Airbnb on the communication infrastructure team. We're responsible for the internal services that send all of our outbound communications. We're going to talk about our communication services and how we scaled them. So before we get started in the technical talk, we want to set some context around Airbnb's business. The details of our business directly affect the decisions that we make, and we want you to be aware of what drives our decisions so that you can make the right decisions for your business. Imagine you're traveling. You booked a place on Airbnb. You're going to a new destination. You're really excited about this new experience you're about to have. You just landed. Your ride dropped you off at your Airbnb. You're ready to settle in and enjoy your stay. You go up to the door. You enter the code, but you can't get in. The door code that you were given doesn't work. It's late. You're exhausted from traveling. You're in a strange place and no one speaks your language. How would you feel? Frustrated? Confused? Maybe a little bit scared? At Airbnb, being able to communicate with guests and hosts in a timely manner is critical to our business. Guest check-ins, check-outs, and other key Airbnb events happen tens of thousands of times a day. Every one of those events require us to ensure those interactions go smoothly. If Airbnb users have a problem, the issue could make or break their entire experience on their trip. A breakdown in our communication can cause real-world pain for real people. We are a global travel and hospitality company. This requires robust, around-the-clock communication. Any downtime or delays in our systems can cause problems for our guests or hosts. Any lapse in communication could cause that person to be less likely to use our services in the future. Timely communication allows guests into their home, allows hosts to notify guests of any changes, and it simply creates a successful experience for everyone involved. Without our robust communication systems, a very large part of the Airbnb experience would just completely grind to a halt. In talking about the Airbnb experience, when you think about Airbnb, what comes to mind? Maybe you think about our website, or maybe you think about our mobile app, or maybe you think about the last place you actually stayed on Airbnb and the wonderful experience that you had. The truth is, most of the time when someone is experiencing Airbnb, they're picking up keys, they're talking to the host, they're exploring the home, or they're just out in the local area exploring. The majority of the Airbnb experience is actually offline. Think about that for a moment. A typical Airbnb user spends a relatively short amount of time on our site finding and booking a place to stay. The rest of their Airbnb experience is on their trip, which could be days or weeks. That's the real Airbnb experience that communication enables. Our communication systems connect our offline experience with our online service. We want to facilitate communication when it's necessary, and we want to get out of the way when it's not. The best Airbnb experiences happen smoothly, facilitated by reliable communications, and that is what we aim for. Everybody's heard the quote, "Necessity is the mother of invention." This is absolutely the case for us. Over the years, Airbnb has seen enormous growth. This rapid expansion has caused an even greater exponential growth in our communication needs. Years ago, we could only send a small number of messages per second. Today, we easily handle over 100 times that volume. There are now more than 3 million homes on Airbnb, located in more than 65,000 cities in 191 countries. We are truly a global company with users in some of the most remote areas of the world. This global presence in nearly every time zone leads to a unique set of communication requirements for our business. So at this point, I want to take a little detour and talk about our history around our communication systems. I want to give you some insight into problems that we had in the past, so hopefully you don't repeat some of our mistakes. Early on, email was the only means for sending emails to our customers. The original Airbnb website actually managed all of this email communication itself. This allowed for quick development, and it mostly did the job, but it had some significant drawbacks, especially as we started to scale. As we did more and more email, the main application lacked a robust way to handle failures, especially if our third-party provider went down. The other issue is, as we sent more and more email, the processing time to handle those emails went up, which caused the performance of the main website to go down. And the performance requirements of a main website and an email service are very, very different. So you want the website to be responsive to the user, clicks, respond quickly. If they're blocked on sending emails to a third-party provider, waiting on I/O, it can take a while. So to solve these issues, we created an internal messaging service to provide more reliability and a separation of concerns. This service handled basic email queuing, processing, rendering, and with the ability to handle successfully failures and retries and things like that. This separated the email logic from the main site, allowing for better performance on both sides. This architecture actually allowed us to scale to the current day. The problem, though, is there's more than just email. So our systems also supported push and SMS. Unfortunately, due to the way that our business and engineering teams were growing, again, those functions were just added to the applications that needed to send those messages. This caused a disjoint architecture where each channel had different implementations, different logging, different tracking, with large amounts of repeated but different logic. This design took us down a path that made our systems difficult to manage, extend, and maintain. So fast forward to today, we've centralized the messaging service to handle multiple channels and built it to a robust notification service for our internal business needs. At this point, that red box right there has a lot of really interesting functionality that we're going to be talking about in the latter half of this talk. The service is responsible for all of our outbound messaging and notifications. When we need to communicate with users, we need the ability to communicate with them on any channel. So for example, we might have guests traveling in areas where they don't have data service. And SMS might be the only way that we can actually reach them. So by working with providers like Twilio, we can greatly improve the way that we contact those users and make sure that we can contact them reliably. So we have a high-level set of requirements for our communications. The first is availability. We need the ability to reach people within seconds. Like I mentioned before, any kind of delays can cause problems. And we need to immediately know if those things are not working. We need our systems to be up 24/7. We accomplish this through data monitoring and alerting throughout an entire system. And there's a little fun fact here. We know so quickly when services are down. Sometimes we actually know that our third-party provider is down before they do. Second is scale. So when we plan out our systems, we plan them out so that we expect a 400% growth over 2 years. That's just based on our historical growth at our company. We also need to handle spikes caused by time of day use. So think about people checking in, checking out. It tends to happen at the same time of day. And then we also support bulk marketing deliveries, so supporting our marketing teams. The system needs to support time-sensitive deliveries along with bulk marketing blasts. Thirdly, we have tracking. We need to have insights into how these messages are being sent, how they're being consumed, so that we can plan for that. The tracking also provides us with robust means to perform near real-time debugging on sent messages across all channels. So you can imagine engineers wondering, hey, did my message go out? They can instantly check our tracking system. And lastly, productivity. We have hundreds of engineers working on product features. We need to make the process of sending notifications as easy as possible for all of those engineering teams. We don't want teams to have to think about things like spam regulations, user opt-out, channel optimization, or other nuanced details specific to communication. We want those product teams to work on their features, and when they need to send a notification, all we want them to say is, I want to send this message to that user, just do it. this point, I want to hand it over to Alvin, and he's going to tell you all the technical details.
All right, thank you, Derek. You guys hear me? Cool. All right, so now I'm going to dive into some of the technical details of how we implement this system at Airbnb. So starting with availability, making sure that we're always up and that our systems are running. So the first thing that we do is we use SmartStack. SmartStack is a system that we use for service discovery in the cloud. So when one service at Airbnb needs to talk to another service, we need to know which boxes that it can talk to. It does this through health checks and constantly updates this data through Zookeeper. You can learn more about SmartStack on our engineering blog post, and this is open source on GitHub. Next is on Kafka. So Kafka is what we use to do publish and subscribing messages across our services. We use this so that services that have different languages, some might be written in Java, some might be written in Ruby, and we need to find a way to make that standardized so that different servers can consume those messages really quickly at scale. Kafka, by design, is built to be redundant, so these messages are replicated across different nodes. We also send the data internally through Thrift. That way, the messages are serialized, and they can be fetched across different languages. The next is what we use is RabbitMQ. RabbitMQ allows us to replicate our nodes so that every single message is persisted on more than one machine. That way, if there's a single node failure, our systems are still up and running. The other thing that we do is we make sure that at the core of communications, we run multiple channels and multiple providers. We know that at any given time, a single provider can fail, and although it happens very rarely, we want to be able to handle that case. And so with our new framework, we're able to sort of change providers on the fly and also make sure that if it's a communication that's really important, let's say like a booking request, what we do is we send that across multiple channels. So in case that an SMS fails or a push fails, at least they'll get the other channel like email. Another important thing with communications in general is that we know that outages do happen. This can happen from a network hiccup, this can be a disk lag, or just anything that is out of our control. And whenever this happens, we want to make sure that that message gets delivered eventually. And so we do this with retries and exponential backoff. Let's say a request fails from an upstream provider. We'll then try again in 10 seconds. If it still fails, we'll try again in 100 seconds, and et cetera, et cetera. This ensures that messages are eventually delayed and not dropped. Next, I'm going to talk about monitoring and alerting. Monitoring and alerting is really key to making sure that we're always available with our systems. The first up is Datadog. Datadog is a third-party tool that we use. It offers a stats implementation so that we can add increments, counters, and histograms. We can see our data over a time series. This allows us to visually see what's happening with our systems and actually add custom rules. So if a certain metric drops to 0, or we see a giant spike in errors, we can have that alert go trigger to our PagerDuty or our other services and be alerted immediately so that we can fix it and see what's going on. Next thing is the RabbitMQ dashboard. RabbitMQ by default offers a UI that you can use to monitor your entire cluster. So with RabbitMQ, we can see the exact message size, the exact number of messages in the queue, the in-out rate, the ingress, egress, and all the other things like memory and disk size. That way we can kind of see an overview of how our cluster is doing and if there's any potential problems. And then we use New Relic. New Relic offers an application monitoring system. This gives a big, good overview of our entire system. It shows us error rate and transaction tracing. Transaction tracing is really helpful to debug issues when your execution time gets really slow. Sometimes you'll have issues where this process is taking too long and you don't know where it's coming from. This can come from database writes, this can come from network lag or anything, and being able to see transaction tracing and see where the spikes are coming from is really key, and that's what New Relic uses, what we use New Relic for today. Next is what we use Sentry. Sentry offers exception tracking so that every exception that's thrown in production gets logged into Sentry. That way we can capture the exact stack trace. We can see specific tags and see the exception count over time. We can debug where the exceptions are happening, how often it's happening, and even on what version of code and what boxes that this exception is happening on. Sometimes an exception is actually only happening on one machine out of an entire cluster, and Sentry is really good at telling us that. Finally, we use PagerDuty. PagerDuty offers a way for us to take alerts and escalate them up to engineering. So whenever there's a downtime or any sort of alert that we write, we can have it trigger PagerDuty, either through email, through Datadog's API, or through New Relic. And so we can quickly notify the correct engineers and escalate to the right team to handle the issue. Cool. So now I'm going to talk about scale and what we did to make sure that we could grow what our business needs. So to set some context, at Airbnb, we send over 15 million communication messages per day. And we also need to handle spikes of up to 120,000 requests per minute. Spikes can come from a variety of reasons, whether that be peak season or certain holidays. New Year's Eve, for example, is our busiest night of the year, and we need to account for those spikes. This also becomes especially challenging at Airbnb because of our fast growth. We need to have enough headroom to sustain our business. So Derek mentioned a bit about this earlier, but in our original design, when Airbnb was small, we could just have the web server directly call our third-party vendors. However, it became quickly apparent that this solution would not scale. The first issue is with failures. If a third-party vendor has an error, we need a way to retry this request. When you raise it at the web server layer, the user will get the error, and they might resubmit the form, which is bad because you might have already charged their credit card or you've already booked their request, and you don't want to do that. The other issue is with timeouts. If a third-party vendor or any sort of network issue happens and the request is taking really long to process, your entire web server layer is now blocked on I/O and can't spend any more time taking in new requests from other users. So we moved on to an async queuing system. So essentially what this means is that requests from our web server gets passed over to a messaging service that then has a responsibility of making retries and waiting for timeouts. So the core of scaling is to make sure that all the work is distributed across multiple machines. One of the things we have to do is that we have multiple queues and multiple workers, which send off to multiple vendors. And so at every given stage of the cycle, our work is distributed across workers. Workers are essentially the bulk of the operation. They do everything from taking in the params, rendering that, whether that be HTML or text, and then logging it into a database or into S3, and then putting it into an API call to whether that be Twilio or another provider, and sending that request over. And so because it does the bulk of the request, we can easily scale that because all of our workers are stateless. We can easily ramp up more boxes or ramp down less boxes whenever we need to. So now I'm going to talk on tracking and what we do to collect details on every single message. So when we look at tracking, we think of tracking as standardized events. We want to be able to have events that are shared across multiple channels and multiple providers. So we made events, and we think of events just like the way you think of events through a UPS or FedEx package. We want to be able to track exactly where did the funnel drop off and what we can do to measure the drop off over time. Here's a screenshot of our internal UI. We also built a UI so that anyone in the company can essentially debug where a message has gone. So all the messages with different channels, push, SMS, and email, we can look up by user ID, phone number, and email address, and see the entire audit trail of where that message has gone and sort of pinpoint issues. This can also be used by customer service to see what's going on with their message delivery. Finally, I'm going to touch a bit on productivity. Productivity is probably one of the most exciting things that we've done this year, and I'm going to talk a little bit about that now. So we support multiple channels, and so to support multiple channels, we have to think about a way that our developers can quickly and easily add new channels. So in the screenshot on the right is actually the entire code that a developer would write to send a push, SMS, and email. That's right, it's only 40 lines of code. It's written in Ruby, and so you can see there's a render push, render email, and render SMS method. You can also make it so that developers can share that language across our different channels. We take the abstraction away from the developer. Underlyingly, we do a lot of magic, but this makes it easy for any developer in a company to quickly write notifications and also be able so that we can support new channels in the future. So here's exactly what that looks like. With that 40 lines of code, it turns into what you see in there, a push, SMS, and email delivered straight to the phone. We also have a UI that we run internally. This allows developers in our company to essentially preview what their template will look like over push, SMS, and email. And so they don't have to push to production. They can just test locally and see exactly what it'll look like before it reaches production. So one of the key parts of developing a framework that supports multiple channels is how we structure that code. We have to leverage a lot on using parent and child classes. At the root, every template supports multiple channels, which we consider multiple child channels, right? And so each one of these child channels can have multiple providers, which are kind of like grandchild providers. And since we have so much providers, we want to make sure that we keep that code as small as possible. The provider code does a minimal amount of work to convert our standardized format of a channel and taking that, putting it to the third-party vendor format and sending it over, taking that response and converting it back to our standardized channel response. This means that the input and output for a provider is the same regardless of which third-party vendor we use. So taking that step a bit further, we also made channel an entire abstraction. So if we ever add new channels, like a push or web push, or we do Facebook Messenger or WeChat, that is really easy now. We've developed a framework to support multiple channels from the ground up, so that in the future, as new users develop new ways of communication, we can easily add that to our system. So now I'm going to talk about the end-to-end lifecycle of a message that goes through our entire system. So this is a diagram showing the entire stack from end to end, and I'll dive deep into each one of these parts. So in the first stage is how we process incoming messages. Messages come in from a variety of places. They can come from a web request, like a user clicking on the page and booking a listing, or they can come from an offline job, whether that's a review reminder or a payment reminder. And these events need to be standardized into our standardized Kafka cluster. And so they get sent in there and published through Kafka, and that other consumers, which can be other services, can then pick them up one by one. So that's where the API consumer comes in. We then pick up the messages one by one from Kafka and process them. The API consumers are actually very lightweight, and they do the very minimal amount of work to just validate the message and figure out which priority that it needs to go into. Based on the priority, we put it in the appropriate RabbitMQ queue for processing. RabbitMQ serves as our persistent queue where it stores all the messages. And it's also a great way because RabbitMQ can handle a large buffer of messages. So if there's sudden spike in traffic, it can be buffered into RabbitMQ and processed whenever there is more load and more work. The next part is processing delivery. This is where the bulk of the operation happens. At the worker level, we essentially take one message at a time from RabbitMQ and do the rendering, we do the logging, and then we do the sending. And we'll send it to one of our third-party providers for delivery. And if there's any failure at the system, whether that be a bug from our developer or there's a network issue, we then requeue it back into Rabbit so that it can be retried at a later time. Again, this does exponential retries and backoffs. So this is the diagram again. This shows the entire life of a message, starting from when a client pushes it in to where it reaches a third-party provider. So now I'm going to touch a little bit about what we think we're heading towards and some of the things that we're looking at right now. So here's what we think are coming up next. The first is on reach. We know that there's more and more channels ever growing, and we want to be able to reach more users in more places. In different geographic regions, different channels are more effective than others. And now that we've designed and built out a framework that supports multiple channels, we want to leverage that and be able to reach more customers. The next thing is on smart delivery. We want to be able to reach customers in the right way so that sometimes a message should come at the right time, at the local time zone, or at the time that they're more likely to view the message. And sometimes we need to throttle the messages so that if it's a promotional message, we want to make sure that we set only a certain amount at a certain rate. And then there's things like channel strategies. Just because we have multiple channels, like we have 5 or 10 channels, we don't necessarily want to send it to all channels. For some users, they only need to use a certain subset of channels. So just because we have push SMS and email, some users might just want to push and just an email, or some just want an SMS. And we want to be smart about that and be able to support multiple channels, but not usually send all of them. And then there's channel failover. At any given time, we know that certain channels might go down, or that certain users might opt out of certain channels and be able to support channel failovers. And then we want to think about compliance. Compliance is a growing area. As more and more regulations gets added every single year, we want to be able to support new rules and add them into our system really quickly. So building out a system and thinking about how we can make sure that new rules with communication messages are added into our system and that we can move really quickly. And then it's on cost saving. As our business gets bigger and bigger, we need to focus a bit more on cost savings and what we can do to make sure that we're being very effective with our cost. So this is going to be things like auto-scaling, QoS queuing. We know some messages have lower priorities, and those messages, we can also cut down on costs. And then looking at provider optimized routing. So looking at which provider can offer better reliability or better options for cost in certain regions. And that's it. So thank you again for your time. Me and Derek will be hanging out here, so if you guys have any questions, feel free to come talk to us. And if you have any other ideas, we'd love to talk to you. Thank you.